Hey there, Algebra 2 students. Welcome back to class. This is Ms. McGuire, and we're going to get started on our Unit 1, Lesson 8 video. So make sure that you're taking notes as you go and follow along. Make sure that you are completing the graphs. Even if you don't have graph paper, you are more than welcome to create a coordinate plane on your notebook paper. Practicing these graphs is really important, so make sure that we're not skipping that. And of course, you're going to have your first and your last name, the period, and the date at the top of your paper for us. So today's lesson is going to be focused on point slope form and standard form. These are both forms that you should have learned in Algebra 1, so hopefully this lesson is more of a review for you today. And today's objective is I will graph linear functions using slope and standard form by identifying key information such as intercepts, slopes, and points. So let's jump right into point slope form. So point slope form is y equals m times x minus h plus k. So this form is when an equation of a line is written such that it looks like this, y equals m times x minus h plus k. Now a couple things should look familiar. This equation includes y and x, just like slope-intercept form. And it also includes m. And m is still your slope, your rise over run. The new information, though, that this form includes is a point on the line. And that point is represented with hk. So we're just saying that the x value of the point is h, and the y value of the point is k. We don't want to represent in the equation that point as x and y, because then we would confuse them with this x and this y. So we're avoiding that confusion by using h and k instead. Some other things that you need to know about this form is that h has the opposite sign in the form, in the equation, than it does in the point. So as you can see, our h here is positive, but in the equation, it's minus h. So if h was negative in the equation, it'll say plus h. However, it's different for the y value of the point. The y value is positive k, and in the point, it's also positive k. So k, the y value, keeps its original sign in the form and in the point, but in the equation, h switches its sign. So that's something that you need to be careful of and watch out for as you are using point slope form. The other thing that I want to point out is that this form includes a point and the slope of the equation. So it includes a point, hk, that's on the line, and it also includes the slope of the line, which comes in handy when we start graphing. So now let's talk for a second about standard form, and then we'll move into some examples. So standard form looks like ax plus by equals c. You might notice that this form does not include m. It does not include the slope. Does not include slope. Instead, this form includes x and y, and then a, b, and c are integers. So a, b, and c are integers, and they have to be integers. A, b, and c cannot be a fraction or a decimal. They have to be integers in standard form. So let me just show you an example of standard form real quick, and maybe this will make a little more sense. Standard form could look like 2x plus 3y equals 7. You might notice then that this is an ax plus by equals c form. A is 2, b is 3, and 7 is c. So a, b, and c are all integers, and c is a constant. It doesn't have a variable attached to it. So ax plus by equals c is standard form. Another thing I want you to notice is that b and y are on the same side of this equal sign. X and y are on the same side of the equal sign. So to be in standard form, x and y have to be on the same side of the equal sign, and a, b, and c have to be integers. Just a couple things to keep in mind about standard form. So let's go ahead and jump into some examples around point slope form, and then we'll come back to standard form. So in example 1, our directions are identify the slope and point given each equation in point slope form. So in example 1, our first equation here is y is equal to negative 2 times x plus 1 minus 4. Well, you can tell that this is in slope-intercept form because it's in y equals m times x minus h plus k. So remember, m is your slope, and h and k are the point on the line. And that point can be any point on the line. So as you can see, our slope, our m, is equal to negative 2. Our point, hk, well, h would be this, in the equation, it's positive 1. So how would you get a positive 1 if you plugged in negative 1 for that negative h here? And then k is negative 4. So let me show you how that would work. You'd have y is equal to negative 2 times x minus h, which is negative 1, plus k, so plus a negative 4. Well, let's simplify that. What's minus a negative 1? Plus 1. And then what's plus minus 4? Plus a negative 4. It would just be negative 4. So as you can see, when h is negative, it gives you a positive sign in the equation. So that's how I knew it was going to be negative in my point, hk. So now look at the second part of example 1. Y is equal to 3/5 times x minus 4 plus 2. Go ahead and identify the slope and the point that is in this equation. So the slope of this line is m equals 3/5, and the point in the equation is 4, 2. So in example 2, our directions this time are write an equation of the line in point slope form given the slope and a point on the line. So in example 2, the first part, you can see that we're given the slope, m is equal to 3/5. And we're also given a point, negative 5, 2. So we're going to plug that slope and that point into point slope form. So remember, point slope form is y is equal to m times x minus h plus k. So m is 3/5, so y is equal to 3/5 times x minus h plus k. So our h would be this negative 5, the x value of our point. So we're minusing a negative 5. And then k is this positive 2, so we're going to add 2. Let's go ahead and simplify our signs. So our equation becomes y is equal to 3/5 times x plus 5 plus 2. Because if you subtract a negative 5, you get a positive. All right, why don't you go ahead and try one on your own? So in the second part of this example, you're given that the slope of the line is negative 1, and a point on the line is negative 3, negative 4. Go ahead and plug that into point slope form and see what you get. So the equation that you should have is y is equal to negative 1 times x plus 3 minus 4. Remember, it's minus a negative 3, so it becomes plus 3. You can also write it as y is equal to negative x plus 3 minus 4, if you don't want to include that 1. It's understood that the 1 is there. All right, let's move on to standard form. So in example 3, our directions are put each equation in standard form. So I just want to remind you that standard form is ax plus by equals c. So we need to put this equation, y is equal to 4/3 x minus 4, into standard form. Right now, the line is actually in, you guessed it, slope-intercept form. It's in y equals mx plus b form. So now we're going to put it into ax plus by equals c, or standard form. So to do that, we want x and y to be on the same sides of the equation. Well, right now they're on opposite sides. So I'm going to move the 4/3 x by subtracting it to both sides. So now I have negative 4/3 x plus y is equal to negative 4. I'm going to go ahead and rewrite it up here so I have a little bit more room. Well, it looks closer to standard form. The x and the y are on the same side of the equation, which is what I want. But if you recall, for standard form, a, b, and c must be integers. Well, negative 4/3 is not an integer. It's a fraction. So to make it be an integer, I'm going to multiply this entire equation by the denominator of that fraction. So I'm going to multiply this entire equation by 3. So what we're going to do is we're going to distribute 3 to negative 4/3, y, and 4. So what happens here is 3 times negative 4/3 is just negative 4. So we have negative 4x. 3 times y is 3y, and 3 times 4 is 12. And now our equation is in standard form. It's an ax plus by equals c. A, b, and c are all 3 integers. They're negative 4, 3, and 12, which are integers. So now why don't you take a shot at this? Check out the equation. Y minus 8 is equal to negative 3x plus 1. Put that equation into standard form. As a reminder, standard form looks like ax plus by equals c. You want to get the x and the y on the same side and everything else on the other side. As you can see, in order to put this equation into standard form, I first distributed this negative 3. Then I moved the negative 3x to the other side by adding it to both sides of the equation. I moved the negative 8 to the other side by adding 8 to both sides of the equation. And I end up with 3x plus y equals 5, which is in standard form. So one of the reasons why we like standard form is because we can actually use it to find our x and our y intercepts of our function. So I'm going to show you how to do that. In example 4, our directions are find the x and y intercepts given each equation in standard form. And that too is a little typo there, huh? That should say in example 4. So let me show you how to find the x and the y intercepts in standard form. Well, if you think about x and y intercepts for just a second. So here's my y-axis and here's my x-axis. If I have an x-intercept, that's the point where a line hits the x-axis. Well, that x-intercept will always have a y value of 0, no matter what the x value is. Then for a y-intercept, let's say I have a y-intercept right there. I know that for all my y-intercepts, I'm always going to have 0 as my x value, no matter what y is for that point. So if I have a line with an x-intercept and a y-intercept, I know that no matter where that intercept is, x is always 0 for my y-intercept, and y is always 0 for my x-intercept. So we're going to use that information to actually help us find our x and our y-intercepts. So to find our x-intercept of negative 2x plus y equals 4, we're going to use y equals 0. And we're going to just plug it into the equation. So negative 2x plus 0 equals 4. See, I just replaced y with 0 here. Well, negative 2x plus 0 is just negative 2x equals 4. Divide both sides by negative 2. So what we've done is we've solved for x, and we get x equals negative 2. That means that this line has an x-intercept at the point negative 2, 0. So there's our x-intercept. Now let's find our y-intercept. So for a y-intercept, you're going to use x equals 0, because x is always 0 for a y-intercept. So we're going to plug in 0 for x into our equation. Negative 2 times 0 is just 0. 0 plus y is just y. So we get y is equal to 4. That means that we have a y-intercept at 0, 4. Now give it a shot on your own. For the equation x minus 2y equals 10, you're going to find the x and the y-intercept. So I'm going to help you get it started. Find your x-intercept, find your y-intercept. For your x-intercept, remember, use y equals 0. And for your y-intercept, use x equals 0. As you can see from my work, I got the x-intercept of this line would be at the point 10, 0. And for the y-intercept, it would be at the point 0, negative 5. Hopefully your answers match up with mine. So now let's move on and learn how to graph using point-slope form. So to make our lives easier with graphing, to make our lives easier when we graph using point-slope form, we have 4 easy steps that we can follow. Step 1 is you're going to want to identify the slope and point. Step 2 is plot the point. Step 3 is use the slope to find more points. And step 4 is to draw a line through the points. So graphing using point-slope form isn't that different from graphing with slope-intercept form. Yes, you're still just going to plot a bunch of points and then draw a line through those points. So the first equation that we're going to graph is y equals negative 2 times x minus 3 plus 1. So remember, excuse me, remember step 1 is to identify the slope and the point. So my h and my k would be 3 and 1. So my point is 3, 1. And my slope is negative 2. So m equals negative 2. The second step is to plot the point. So we're going to plot 3, 1. The third step is to use your slope to find other points on the graph. So our slope is negative 2. Negative 2 is technically over 1. So our rise, or in this case our fall, is negative 2, and our run is 1. So we're going to fall 1, 2, run 1. Fall 1, 2, run 1. And then in the opposite direction, we would go up 2, left 1. And here we have a bunch of points that we can go ahead and draw our line through. I'm going to make this line straighter. All right, and then this graph is just missing a bunch of labels, so I'm going to label it real quick. We need our x and y axes labeled, our dashes, with every other number on our scale labeled for us, so it's super easy to read. And then our negative x-axis. And there we go, our graph is all done and ready to go. Why don't you go ahead and graph equation 2 in this example on your own. The equation I want you to graph is y is equal to 3/4 times x plus 2 minus 1. So remember, step 1, identify your slope and the point. Step 2, plot the point. Step 3, use your slope to find other points on the graph. And step 4, draw your line for your graph. Don't forget to label your graph. As you can see my graph here, I found the point -2, -1 from the equation. I identified my slope of 3/4, and this is the graph that I got. So I plotted -2, -1 first, then I used my slope, my rise 1, 2, 3, and my run 1, 2, 3, 4 to find the other points on this graph. Hopefully your graph looks like mine. Let's move on to learning how to graph a function using standard form. So with standard form, our steps change just a little bit. Remember, with standard form, we were able to find our x and our y intercepts. So we're going to use our x and our y intercepts to actually help us make our graph. So step 1 is you're going to want to find the x-intercept. Step 2, find the y-intercept. Then step 3, plot both of those points. So plot the x and y intercepts. And then step 4, draw the line through those points. So let's do this for the first example here. Example 6 in the first part. X plus y equals -3. So x plus y equals -3. Remember, step 1 is to find the x-intercept. So I'm going to find my x-intercept. To find it, I use y equals 0. So I'm going to have x plus 0 equals -3. So x is -3. So my x-intercept is -3, 0. Then we need to find our y-intercept. To find your y-intercept, you use x equals 0. So 0 plus y equals -3. So y is -3. So we have the point 0, -3. Then we need to, what was step 3? Plot the x and y intercepts. So we're going to plot these 2 points, -3, 0, 0, -3, and then draw the line through them. Make sure your line goes all the way across your coordinate plane. And then, of course, don't forget to label your axes and your scale. So I'm just going to label those real quick. All right, now it's your turn. So for the next part of this example, I want you to graph the equation 3x minus 2y equals -6. And this equation is in standard form. It's in ax plus by equals c form. So you want to graph it using your x and y intercepts. So find your x-intercept and find your y-intercept, plot those 2 points, and then draw the line that goes between them, or goes through them. As you can see for this equation, I got my x-intercept is -2, 0, and my y-intercept is 0, 3. I plotted those 2 points. I've got my x-intercept, my y-intercept, and then I simply drew the line through them. So that's all for today's notes. Thank you for participating in this lesson. You may go ahead and start your homework when you are done with this Edpuzzle. Have a good day.